Hi, in this video, I'm going to talk about my project in Big Data Analytics class at Columbia University. My project is on service status analysis on BART, Bay Area Rapid Transit, which is a transportation, sort of a train service in San Francisco. And it has lots of delays and service outages. So I'm going to predict the service change first and try to predict its degree based on past data. So this is what I initially proposed in the proposal stage. I was going to analyze text and image, and I did it, but not using third-party platform because of the learning curve, and I wanted to make my own models. So there was also change from the midpoint stage. There is a website called Twitter Historical Archive, offered as a free service to capture lots of tweets, and it just wasn't too good enough for me. The model for binary classification wasn't that good, and there was lack of concrete data, and it's to me huge time to clean the data. About 1 terabyte per year chopped into single tar and JSON per every hour. So that meant 24 JSON and tar file per day. You can do the calculation, and it wasn't that good, and the data was too small. So I decided to move on to Premium Search API on Twitter, which is basically a subscription service that I paid to make a query. So I used about 225 query to make a search all the way back to 2013, I think, the first time when there was an alert for the change in San Francisco BART. Oh, actually 2012. So this is a query example of a query I made on Twitter developer API. I can customize all the keywords and what I don't want for this query. For example, I don't want any retweet. I don't want any official announcement from the SF BART or SF BART alert. And I want some hashtags on BART and SF BART for such query. So on the right, you see the examples of raw JSON file I captured into every 2 weeks or so, and this is the raw Twitter object I received back on post request. So I first collected about 100,000 raw tweets, and there were lots of steps to refine this data. I transformed the raw data and I refined the official tweet to see any delay. And if there's any delay, I try to store the degree of delay, which is the time, and store the mean value, and do the same thing for outage. And if there's any location, I just store the location as a different array. So if you see on the right, this is one event happened in 2012, July 8th, at around 3 p.m. So this is around 10 to 15-minute delay with the locations captured, parsed from the Twitter. And I also matched regular and official tweet. What I mean by official tweet is the official announcement by SF BART to capture specific time interval. So if there's any, I think 30-minute to 1 hour interval between the regular tweets by the users and official tweet, I mark it as irrelevant. And I validate the status change by cross-checking with the BART ridership reports. And I also created different categories for different degrees. I also performed basic one hot encoding for classification. Yeah, just so I refined down to 9,000 tweets and about 500 tweets with images. So this is basically the input I made for my machine learning model. I have multi labels. Each tweet can have more than one label, of course. So this is one hot encoded, so it's gonna be 1 and 0. So this is just an example of indexes I made. So 1 and the rest of the indexes 0 will be marked as delay, and 1 will be delay or delay 15 minutes, and so on. And yeah, if you see the third example in the gray box, you see the example with the image as well. So I decided to drop locations at this point because it was really hard to parse the exact location. and I couldn't get the geolocation data due to bottleneck of money. And if there's any business value, then company can spend more money on it. So yeah, location should not be predicted, and I wanted to focus on proof of concept for this project. So this is text analysis of all the tweets I gathered. This is a list of steps I took in the machine learning model. So this is the neural network, bidirectional LSTM, and accuracy came out to be close to 88%. Yeah, this is some examples I was able to go through. You see different examples of actual tweets I tested with, and I can also distinguish Bart from Simpsons from Bart in San Francisco, and he was a big bottleneck. And I this model distinguishes Bart from Simpsons as something not applicable, so nothing relevant. Same goes for image. Um, I have hand labeled not applicable, bad images and good images out of the past images with past tweets with images. And if you see on the right, I have a screenshot of a BART, and this is something I don't want. Something on the left, people waiting train, is something I want to train my model. Um, and this is a little bit more complicated, but it's basically CNN, convolutional neural network. And I was able to get around a little bit better than the text analysis, maybe because there was a little bit lacking of a text refinement. And this is the result I was able to get, delayed 15 minutes, 30 minutes. And something not applicable, cat waiting on a empty train station, actually BART station, and something cave, like it's dark. But there was also something a little bit fishy as well. This is a train in New York City, and this is marked as delay. And on the right, this is a picture, just random picture of people, but it's marked as outage or not applicable. Maybe when there's outage, people wait outside and it's rather bright. I don't know, but yeah, this is something fishy I got. So I'm gonna demo now for this some what I got. So this is a little bit of a local hosted React front end of demo of what I wanted to make. So I have a civic center. So I'm actually deploying a TensorFlow JS model and then getting this calculation right away. So I just got it as delay, and this is BART. And if you see a console log, I'm actually logging the internal model and the original text and prediction to show that these are not actually hard coded. So I'm gonna show with a dynamic string right now. So let's type something totally irrelevant. On my way to watch movie. So yeah, this will be something usual on Twitter. Yeah, not applicable. And something, it seems like train is not coming to this station. Cool, delay. Something more severe and okay, something like I see police everywhere in this station. Cool, delay 15 minutes. And same goes for image. It was a little bit hard to deploy streamlining image analysis online. So this is a Google Colab model I have. I'm basically processing the data here. Okay, and I'm making the model, and I'm loading the saved TensorFlow model, and which is saved on my Google Drive. And yeah, it was really fast. I just predicted this delay for test image 11, which is this one. Cool. Yeah, and here's a little bit of a snapshot of my code to deploy TensorFlow JS. I actually implemented everything in JavaScript. Thank you.